So now we are ready to answer the question, how many units should we produce in order to maximize our profit? So to do so, we are going to think in terms of margin. So the product market is perfectly competitive, and the price, the market price, P is the market price. So on the firms, I can sell my product, sell my coffee at the market price as many as I want. Okay, so let's think in terms of margin. So if I produce zero output, starting from zero, okay, yeah, I want to ask, should I produce the first unit, extra 1 unit on top of zero? Okay, what's the actual revenue? Which is marginal revenue. If I produce this extra 1 cup of coffee, I can sell in the market for price $4. And what's the extra costs? So extra costs. Okay, let me have it. Which is marginal cost. Let me say, okay, price is this is coffee is $4.50. The marginal cost could be the extra cost associated with the first coffee could be let's say is $3.50. Okay, worker hours, the coffee beans, so on and so forth. Okay, then the decision on this first coffee is yes. Now on top, I have decided to produce at least 1 coffee. What about second? Okay, if I produce second cup of coffee, I can sell this cup of coffee in the market for extra revenue of $4.5. So that's marginal revenue. On the cost side, to produce this extra 1 cup of coffee, the extra cost, the associated marginal cost, let's say is $3.80. Then the answer is yes. Okay, and you can see that now compared with the previous unit, the marginal cost increase. Okay, and this is due to a law of diminishing return. Okay, so I've decided now to produce 3 coffees. What about third one? If I produce the third one, have the same similar reasoning. If I produce the third one, extra revenue is $4. Extra cost now is going to be higher than previous one because of law of diminishing returns. Let's say is $4.20. So now marginal revenue, extra revenue is higher than extra cost. The answer is yes. Let's keep to 4. The marginal revenue is 4.5. The margin cost, suppose is 4.5 now. So now I'm fine. So, okay, for this particular cup of coffee, we break even here. So let's say, yes, we will produce this. What about fifth coffee? If I produce it, I sell in the market for extra revenue, margin revenue of $4.50. The extra cost now is $4.80, suppose. And it increased compared with the previous one due to the law of diminishing returns. Okay, now for this fifth cup of coffee, the answer is the decision is we should not produce this cup of coffee because extra revenue, marginal revenue is less than marginal costs. So our optimal units output is 4. We need to produce 4 cups of coffee so that we can maximize our profit. Okay, in doing so, you certainly want to be aware that we are think in terms of margin. We are having marginal thinking here. All right. So in the end, you should observe that the solution is choose quantity such that MR equal to MC. Marginal revenue is equal to marginal costs. All right. Let's solve this problem more rigorously or algebraically. So we are going to form the profit. So we have Q output price, the market price, that's total revenue, and we have total cost. C is a function of Q, that's the total cost. So profit will be equal to total revenue, take away total cost, and it's equal to P times Q minus CQ. Okay, what we want to do is we want to maximize quantity or maximize the profit by choosing quantity. Okay, in order to maximize the profit, the function, we have first order condition and second order condition. So first order condition is differentiate profit with respect to quantity. So we get this does not depend on Q because we are assuming the product market is perfectly competitive. So, and there's a Q here, so it's P minus differentiate cost with respect to Q, and we actually call this marginal cost, MC, or P minus MC. And you want to be aware that price, because we are in a perfectly competitive market, the price is the marginal revenue for the firms, and set to 0. This implies P is equal to MC, or more generally, marginal revenue is equal to marginal costs, as we did, as we arrived at in the example above. All right. First order condition, second order condition. We need to check this. Evaluate at let's say Q star, the labor output. The labor output solve this equation. So it's equal to differentiate the first derivative one more time. So it's minus evaluate at the solution. Okay, and generally we are going to assume that this cost function is eventually is what we call convex, and that means the second derivative is positive, and this could be is due to the law of diminishing returns. So this term is positive. We find that the whole term is negative. Okay. So the second order condition is negative. So this ensures that what we found is indeed the profit maximizing labor output. All right. So the golden rule here is that choose the quantity so that MR equal to MC, marginal revenue equal to marginal costs, if we want to find out what labor output we should produce so that we can maximize our profit. So that's profit maximizing analysis. Sometimes we only want to find out the break-even labor output. So we can have break-even analysis. Break-even analysis. Okay, so what we have in hand is we know total revenue is equal to price times quantity. We know total cost is a function of quantity. And okay, for the purpose of demonstration, I'm going to say P is $5, so 5 cube, and I'm going to give the quantity, the cost function as very specific functional forms. Let's say 10 plus q 10 minus q, let's say, plus 1/2 q squared. Okay. And the break-even analysis, we want to find q, the labor output, such that we break even, or profit is equal to 0, or total revenue is equal to total costs. Okay, so let's again have profit is equal to 5q minus 10 minus q plus 1/2 q squared. 5q minus 10 plus q plus q squared. So it's 1/2 q squared plus q minus 10. We can actually draw this function pi q. If q is equal to 0, pi is negative 10. If q is equal to say 10, q is equal to 10, it's 50, profit is 50, something like this. The curve something like this. So the cost, the what we want is this q. That's the break-even level output, and we can apply. You should know that this is a quadratic function, so we can apply the formula to find the root of the quadratic functions. So the solution is q is negative 1 plus. We are going to, usually you're going to have a negative here, plus and minus, but minus, if it's minus, it becomes negative. That's not what we want. Or something like, okay, something like this. Okay, this is what we want. So 1 minus 4 times 1/2 times minus 10. 2 minus 1. 2 times 1/2. 1 plus 21. So it's roughly 21 minus 1. Okay. So that's the break-even output, and this is break-even analysis. We can also actually do it graphically. So total revenue, like this. We can do this break-even analysis graphically, like this. PQ, so it's 5Q. So this is total revenue. Total cost is something like this. So break even should be here. That's the break even level output. All right. Okay. This is how we can use the cost function to find out the profit maximizing level output and to conduct a break-even analysis.